everyone, my name is D.K.RAJAN and my group will be presenting the mini project 1 for data structures. I'll be doing the presentation for question 1 as you can read here. Now, the coding part for the question. First question, the beginning here, I have declared my stack, my variable and also my array size. Next, the following part. Here is where you receive the input from the user to enter the stack. Once this is done, the next part is just to display all the data in the array in the stack in the right order. Then the following part is where the pop operation will be activated. In here, you show the data in the stack array will be popped out. Next, the following part, last part here, in here is just to show all the operation, the code has run correctly, because in the end the stack should be empty. Now let's run the code to make sure everything is in order. First I enter the first key, second, third. As you can see here, first I've entered each of the data PUO, and here you can see the data entered in the array is right. First one is P, where the top value is 0, second one is U, the top value is 1, and the third part is O, and the top value is 2, and the stack is full. Next, you can see the pop element starts with O, which is right, because in stack the last element should be popped first. So O goes out, then U, then P, and in the end it shows the output stack is empty. Therefore, we have fulfilled the conditions of the question, and now my friend TASHVINDRAN will continue with the second question. Thank you.
Hello, my name is TASHVINDRAN and I'll be explaining question 2 on our mini project. So in the first line of code, we have declared our word P, U and O as separate letters. So letter 1, 2 and 3. So then we declare our queue, which contains the element of front, rear and list, and we declare our queue as the variable of my queue, as you can see here. Then we have declared the function of DQ, which we'll be using later. Now in our main function, we have initialized our integer I for the use of in the console. Then we have set front and rear as 0. Then we have initialized our letter 1, 2 and 3 as P, U and O. So now to enqueue, we have to make sure our queue is queue is not full. Then if our new queue is not full, then we can insert our elements into rear and letter 2 and 3 into the rear and increment our rear by 1 rear pointer. Then to check, we have to use the for statement and see out our list into the console. Now to dequeue our element, we have to check if our queue is empty or not. If it's not empty, we can dequeue, which is why in the function dequeue we show our element front, then we increment it by 1 so that P is shown, then it is removed, then U is shown, removed, and so on. So if you see in our structure here, if we run our code, you can see P, U and O have been added into the queue. Then later on, it has been dequeued by our code. So that's how you make code for queue. And that's all from me. Thank you.
Okay, thank you TASHVINDRAN. And now, hi everyone, my name is JEEVENEISH and now I'm going to be explaining question 3 about our mini project. As you can see in question 3, what they mainly ask for is a C++ program that shows the implementation of inserting into BST, count item in BST, creating a BST, deleting item and traversal, which I'll show you right now with my code. As you can see, this is the group, this is my group. And starting off, this is how you create a BST. Okay, this is the coding line that you use to create a BST. Now, this is the coding line that you use to implement your count. So when you run, this will show you how many nodes you have in your BST. Now, this is the code that I used for deletion. I have 3 types of deletion, which I'll explain later. Now, we have void in order, void pre-order, and void post order. These are the traversals of the BST. And this is insertion. this is how you insert. For example, here I've inserted 50, 30, 20, and so on. And this is all the output statements that you'll get once you click run. Now, let me show you. So after you run the code, this is what you'll be popped up with. As you can see, count. Number of nodes in this BST is 6. And these are all the traversals that the question has asked us in order, pre-order, and post-order. And then this is deletion. 3 types of deletion was deleting a leaf node, deleting a node with single child, and deleting a node with both childs. So as you can see, these are the outputs for deleting a leaf node. These are the outputs for deleting a single child node, and this is the output for modifying a BST tree after deleting both child node. So that's about it. Thank you.